All right, before we get into lesson 2, we have to review some of our Algebra 1 exponentiation rules. And so there's some rules for simplifying exponential expressions. We want to make sure that you know how to do that because I know it's been a minute since you took Algebra 1. And so if we can review that Algebra 1, it'll make it so that you can handle the Algebra 2. Again, most of what we do in Algebra 2 is everything from Algebra 1 with like one extra step. And so here, we're going to take those fractional exponents, right, those rational exponents that we had from writing our radical expressions as, or in an exponential form, but we're going to combine that with those rules of Algebra 1. So we're going to have all those rules of Algebra 1, but what if those exponents are fractions? That's basically how we're going to mess with our work today. Or for our work in the first part of lesson 2. But in order to do that, let's review this Algebra 1. So I've got 5 examples, 5 key properties, and then of course the examples that go along with it. I've got 2 for each one. So here our first property is that anything to the 0 power is equal to 1 as long as that base does not equal 0. So anything raised to the 0 power is equal to 1. So here, this to the 0 power is going to equal 1. That's it. Right? Nothing fancy to do there. Here, this exponent is the 0 power. And so we have this to the 0 power means that our numerator is 1. And this denominator doesn't change. All right? That's it. This is the first property, which states that anything to the 0 power is equal to 1. All right? As long as that base doesn't equal 0. For the second property, we have that any product of powers we will add the exponents. Again, the way that we did that, if you remember from Algebra 1, they said, well, what if you have a squared times a cubed, and they wrote out that you have a times a multiplied by a times a, which means that you get 5 a's total, 2 plus 3. All right, not 2 times 3, 2 plus 3. So in this case, when we have these multiplied together, we have the numerical parts, 3 times 4, but then we have the exponential parts, the variable parts, a squared and a to the 6th. So since these are powers of the same base, we're going to add those exponents. So this is going to give us 3 times 4 makes 12, and then a to the 2 plus 6, which gives us 12a to the 8th power. Not 2 times 6 to get 12 as the exponent, but 2 plus 6 to get 8 for the exponent. Over here on this one, again, I'm going to show this out writing separate steps here. I'm going to do negative 6 times 3. I'm going to do the x squared times x. Now when it says times x, that really means x to the first power, and I want to make sure that you know that and believe that. And then we've got y squared and y cubed. We've already done a squared and a cubed to kind of show what that looks like. So this gives us negative 18, x to the 3rd, y to the 5th. All right, when we multiply that together. So again, powers of like bases, when you multiply powers of like bases, you add the exponents. All right? Example 3, or the third property. The third property says if we take a product to a power, we give the exponent to both factors, or all factors. If there's 3 or 4 or 5 factors in there, we're going to give that exponent to each factor. And it also shows us that if we have a power to a power, that we multiply those exponents. So we're kind of doing 2 things here. I've got 4 times this thing to the negative 2nd power. So the 4 does not have that negative 2 exponent. All right, you're like, negative exponents, what the heck is that? We'll chat about that in just a second. But here we have the 4 on the outside, that's still going to be there. But then I'm taking this power to a power. So I have x to the negative 3rd is going to be to the negative 2, and I've got y to the negative 2nd to the negative 2. I'm giving this exponent to the x to the negative 3rd, and I'm giving the exponent y to the negative 2nd. So that means I've got 4 times x to the negative 3 times negative 2 times y to the negative 2 times negative 2. And so that is going to give us 4 times x to the positive 6, y to the positive 4. Notice how the number in front didn't get the exponent, so we're not going to mess with it. All right, and then over here, again, now this 2 is inside, so we're going to have 2 gets cubed, x gets cubed, y cubed gets cubed. That's a 3 in some cultures. I got bad handwriting. And then we also have z to the 7th gets cubed. All of those things get cubed. 2 cubed we know already is 8, x cubed, oh, that's just x cubed, right? That's easy. Y to the 3 times 3 is y to the 9th, and z to the 7 times 3 is z to the 21st power. So we want to make sure that you can do these operations. Now, if you skip showing this step, that's fine as long as you get it right. If you skip this step and you get it wrong, then why did you skip that step, right? That's kind of the fundamental problem with math, is that sometimes we wanna skip our steps, and then when we do, we make mistakes. All right, example 4. Let's get this one going. Example 4. So this property right here is, again, our quotient property. When we have a to the m divided by a to the n, so powers of the same base but divided, we will subtract. Likewise, if we have a fraction to an exponent, we give that power to both the numerator and the denominator. Just like when it was a product, we gave the exponent to both the to both factors there. So here we have some very similar expressions here. There's kind of a lot happening, so we want to do a good job with this. Here we have r squared s cubed t to the 4th. But in the bottom here, we have this product to this power. So that means we get r squared, s to the 2 times 2, and t to the 1st squared, which is t to the 1 times 2. And so that gives us this situation. Now you can separate those out if you would like to. This may be healthy to recognize that you've got r squared over r squared. You've got s cubed over s to the 4th, and we've got t to the 4th over t squared. All right, so what this means for us is if we're following this rule right here, we're going to do subtraction. So this means that we've got r to the 2 minus 2, s to the 3 minus 4, and t to the 4 minus 2, which gives us r to the 0, s to the negative 1, and t squared. All right, now anything to the 0 power is equal to 1. We're going to talk about a negative exponent on the next slide. This means 1 over s. This is going to be 1 over s. And then we've got t squared. If I multiply all those together, right, this 1 times 1 over s is just 1 over s. 1 over s times t squared is going to give us t squared over s, all right, using just positive exponents. All right, we're going to talk about that negative exponent issue on the next slide. All right, so then over here, now we've got this product. We've got quotients happening. We've got powers with fractions. There's a lot going on here. So we've got this same first thing. Nothing changes over here. But for the second part here, we've got s cubed, we've got r cubed, we've got 4 cubed, and we've got t cubed. And so now we've got to put all these things together. Well, just like when we simplified fractions in our last unit, we've got some repeated stuff, which is awesome. So I've got 1 t cubed and another t cubed. I've got 1 r, and I've got r squareds, right? So I'm down to r squareds. I've got my s's that can multiply, and then I've got my 4 cubed in the denominator. So this means I've got s squared times s cubed, which is s to the 5th. In our denominator, I've got 4 cubed, which is 64. Oops, I forgot my r squared. There we go. So I've got s to the 5th, r squared over 64. Rule number 5 is the one with negative exponents. So if we have a negative exponent, that means 1 over that base with the positive power, all right? So we'll flip it and change this to a positive. 1 over something with a negative exponent, so if our negative exponent is in the denominator, that just means that we can make the exponent positive and put it in the numerator. Notice how a doesn't change signs. If a is negative, it's still negative. If a is positive, it's still positive. But the exponent changes, all right? A negative exponent does not mean negative number. So let's take a look at what we've got here. When we have p cubed to the negative 2nd power, we're going to do our power to a power property, which means we have 3 times negative 2, which gives me p to the negative 6th, which means that I've got 1 over p to the 6th power. Over here, let's put this in here first, because I think it's going to be a little bit more valuable if we do it that way. This is going to give us 2 to the negative 2, r to the positive 2, s to the negative 4, t to the negative 2. And all that is divided by 2, r, and s. All right? So we've got a couple common bases here. So we can do a little bit of work like we did with the division. So now I've got 2 to the negative 2 minus 1. I've got r to the 2 minus 1. I've got s to the negative 4 minus 1. And then I've got t to the negative 2. So this gives me 2 to the negative 3rd, r to the 1, s to the negative 5, and t to the negative 2. Since we can't have negative exponents in our final form, this is the only positive power, and so that stays on top. Everything else will go to the denominator with positive exponents. Now again, if this is a negative number, it's going to stay negative, right? but that's not the case. Here, this is a positive 2 to the negative third power. It's going to be 8 in the denominator. We've got s to the positive 5 in the denominator and t to the positive 2 in the denominator. All right, so those are our rules of exponentiation from Algebra 1. All of that was a review, and we're going to practice that in class. I've got 4 practice questions, and that is just to make sure that we get some time to discuss either confusion on your Algebra 1 or just to make sure that we can actually practice that together. It kind of forces us to do that practice, which is kind of what we're used to doing in this class.